welcome to the interview talk series by the students of IC Bhopal. This is a joint initiative from the Maths Club and the Photography Club. Our guest for today is Dr. Nikita Agarwal, and hope you enjoy. So, Dr. Nikita Agarwal is an associate professor at ISL Bhopal. She has completed her BA Honours from Lady Shriram College in Delhi and her MS and PhD from the University of Houston, Texas. Her work is focused in pure and applied dynamical system and algorithm theory. She is also an active member of the Indian Women in Mathematics. So we are glad that she was able to find the time to discuss a little about her journey with us. Thank you, ma'am, for joining us with this interview. To start off, we have a little personal question for you. As with many life choices, there are often times when there are like a defining moment where one decides to commit to a particular path. So could you describe the significant turning point in your life when your passion for mathematics was sparked and you decided to dedicate your life to it?
So first of all, thanks Yashaswini and also the Math Club for organizing this interview. I hope my comments are going to make a difference. So about your question, I always liked doing mathematics since childhood. I liked solving puzzles, doing math homeworks. That used to be the first thing I get back home and so on. And I chose mathematics for my undergraduate degree, but that was just because I liked mathematics. I had no long-term goal at that time. And to my surprise, I came to know at that time that mathematics is nowhere near what you know of mathematics at school. Now you are not solving problems by given set of formulas, but you are deriving your own formulas and there are theorems and proofs. But I really liked that logic and abstraction at the same time, and I think by the end of bachelor's I knew that mathematics is what I want to do. I got admission into a master's and PhD program, and then there was no looking back. I knew that it is only mathematics and there was no fallback option for me. So yes.
So could you share some specific mathematical concept or problem that captivated you during that time?
So I'm teaching a course in real analysis this semester, and I told the students of my class also that one particular result that all analysts use all the time is Archimedean property, which basically says that given a real number, there is a natural number bigger than that real number. So this is an undervalued result which all of us take for granted, but actually it is very powerful. And I think at least in my class I would have used it at least 100 times already. And it is so at bachelor's level I realized that it's important, but ironically during the interview for my master's program, the interviewer asked me, can you give 10 equivalent statements of Archimedean property? So, that's when I realized that, oh, is it that powerful that, the interviewer is asking me of 10 equivalent statements. And I think I was able to, I don't know the exact number, but 7 to 8 equivalent statements I could give, because I was already thinking a lot about that statement at my bachelor's. So that is one of the results. So the message is, it's not about Archimedean property, but the message I want to give is that we tend to undervalue many small things and we just take them for granted, and it is not like that. One has to be careful. And
so it's famously hard to publish papers in mathematics, and math students most often don't see a publication until their PhD, which is not the case in many other disciplines. So my question is, when did you first publish? How was the whole story surrounding that? And is it very different compared to publications in other disciplines?
So it's true that it is the time you conceptualize the problem to it actually taking a form of publication itself takes a lot of time. Then from there to actual acceptance and publication is another, long journey. And my first publication was in fourth year of my PhD, and it actually took about a year to from submission stage to acceptance stage. And after 6 months of submission, I was starting to feeling nervous because in 1 year time you have to graduate. You don't have more fellowship, you are in a foreign land, what if they deport you, what's going to happen, all kinds of thoughts started to come in. And but of course my supervisor was telling me, work is good, you have worked hard, and don't worry, this is standard. But as a student you don't accept it. Okay, it is standard in mathematics. Even today when I tell my students it, be patient, it's standard, it doesn't help them, because what it is you are a student and you don't have much experience, and you look at your peers in other departments, especially in ICERs, right? You mingle a lot with other departments, and they are publishing left and right, and even at fourth year, fifth year of undergraduate, and you are nowhere near. Forget about publishing, you're not even solving a problem which is unknown, right? You're just reading. So but at the end, when the publication got through, I was very, very happy. uh, but I must tell the students that having delayed publications or having less number of publications, one should not get demotivated by it, because at the end of it you are being compared with fellow mathematicians, right? You are being compared within your community. When there is any kind of appraisal, your benchmark is not what your fellow colleague in chemistry or physics is publishing. My benchmark is what a fellow mathematician at my same level is publishing. So within the community, this is very well known that in different areas the number of publications can be very different, even in mathematics. You see, not, you don't compare it even with outside mathematics, even within mathematics it's very different. So this is the baseline, and one has to really accept it and move forward. It should not dissuade you to not pursue a career in mathematics.
So could you share one of your most memorable projects from undergrad or masters, and which left a lasting impression on you?
So, to be honest, I did not do much of mathematical projects beyond the classroom learning like today students do. At that time, if there is a holiday, you go home. You don't do internships. So this is a very recent phenomenon that you do this project, that project, this fellowship, that fellowship, and so on. It's very recent. I would say in last 5 to 10 years this has really picked up. And many a times it is out of interest that you do a fellowship or internship, or just to have something on your CV, okay, to be honest. So but what I remember two things that are not mathematical projects, but that really shaped me as a mathematician and also an individual. One was that I was on the editorial team of a department journal. We were not publishing anything new. Students were contributing something that is beyond the classroom topics, but one thing I remember in the journal in which I was involved was giving a proof for that the sum of first n natural numbers is n times n plus 1 by 2. So there was a geometrical proof, and then this idea, geometrical idea, can be extended to sum of cubes of first n natural numbers, things like that. So that gave me an experience of research at a very young stage, because even though they were not original topics, but you were doing research, you were finding about the topic, you were doing something beyond your classroom. That really made a difference, and I was introduced to research at a young age. Second was more at non-mathematical, was that in my college there every student was mandated to join one of the three groups. One was NSO, which is student organizations. Second was NCC. Third was NSS, which is social service scheme. And I opted for the third one because I was not too much interested in sports and also cadet corps. So I chose NSS, and I used to go to a school for physically disabled kids, and certain number of hours, I think 12 if I remember, we had to spend every week. And you would go there, you'd play with them, you'd also teach them very basic mathematics and so on. So I really liked that, and that shaped me as an individual. So these two things, academics is one thing that one should pursue while in college, but you should also get involved with something else. It could be sports, and you are in a very privileged environment, which is ICERS, where you have everything there, right? So you should take full advantage of that.
Could you elaborate on the importance of networking and collaboration? And like, can it open up research opportunities for students? How important is it in a field like mathematics?
Very, very important. So one of the things that as students, even undergraduates, or more specifically for research students, that one should be doing is having student seminars, having like math club, right, where you people organize. I know at late night you have these seminars which one of you present on topics, or solving some problems which may not be open research problems, but some question that interested you, and you're coming together and solving them. So having peer groups, having seminar series, sometimes, actually many a times, especially for research student, it can turn into a research collaboration when you are actually in the field. So you are working in different areas or similar areas, you discuss, you say, oh, I am also doing this, right, which is very similar to what you are doing, but from very different directions. You come together, put those two ideas together, and then you get a really good quality of work out. So collaborations is definitely very important, and it also breaks monotony in mathematics profession. As a mathematics professional, you are just, if you are a pure mathematician, as is called, you are solving things on paper and so on. You are not meeting anybody all day, you are just into your research problem. So if you have a group to talk to, it could be your students, postdocs, or your research collaborators, you talk about academics, plus also you have tea with them, coffee with them, you talk other kinds of things. It breaks that monotony. So especially in mathematics, having a group or collaborations, even though it's very rare, I must say, but it's very important, especially in mathematics, I feel. Yeah.
So many undergraduate students are passionate about mathematics but may not know where to start or how to get involved in research. So what advice do you have for them? So like, how can students engage in research at this level and make their time at undergrad worth it?
So actually in mathematics it's very natural to get into research, and this is kind of not talked about much, but recently in 2-3 years I'm trying to bring this thought out, is that when you read a theorem, there are certain hypotheses, and then you say if these hypotheses are true, this is true, right? So now you ask questions like, if one of these hypotheses fail, then what happens, right? And many a times the final statement is no longer true, right? That's the first step for research, right? You are trying to look at a result which already exists. You are trying to see if this fails, what is going to happen. It opens a research question for you, right? It may still be solved, but for you it's a problem, right? It may not have a solution in your book. So then you research, okay, you need such advanced techniques to be able to answer this question. That would have led to development of some other advanced field of mathematics. So for undergraduate student, an undergraduate student, I feel, should be encouraged to ask such questions. It should not be just, I go to the class, I write theorem proof, and that's it. I should pose these questions that, okay, let us drop this hypothesis, what's going to happen. I myself as a teacher may not know the answer because it may be beyond my expertise or it's still an open question, but it is my responsibility to bring that out. And as an undergraduate, if you start posing those questions, you will see that you will start enjoying mathematics. Then it's not just like theorem proof. There is much more beyond that. Yeah, so this is one of the primary steps, I feel, when an undergraduate can be involved in research.
So finally, we have a question. As a female researcher in mathematics, have you encountered any challenges specific to your gender? Because this is usually a male-dominated field.
So I would say that I've been mostly fortunate on this front. Even though I remember when I got enrolled in bachelor's program in mathematics, and also when I went to the US, not my parents but the extended relatives or neighbors would say, acha, why is she doing mathematics, what is the future, it's not for girls, and so on. But one has to close their ears. One has to be one has to shield themselves from such ideas. So my parents were very supportive, so therefore I didn't really have much of a hurdle. I had really good professors. As I said, I was in an all girls college, so there was no such bias coming in and so on. But I do know that it's for a fact that women face hurdles in pursuing mathematics, and it's more of a mindset issue rather than anything that physically exists. It's more of a mental, cultural, biological, social thing. And one thing that I have faced, which most women face, is especially when they have family responsibilities. And for women, it's not just with mathematics per se, but women are tend to make are it is a notion that women should take care of family first, even if it is at the expense of your job responsibilities, right? So job always takes a back seat and it's always family first. So that mindset has to change, and there has to be a collective effort of family to promote the women in the family to be able to take up jobs in mathematics or sciences or even in STEM fields, right, where it's the talk of the town, right? There are so few women in STEM. So that's one. And finally, I will say that every woman should identify role models or mentors who can also be inspiring for them and also can guide them from time to time. And there are very few role models, there are very few women mentors, because the number of women in maths is small, so therefore the role models are small. So there should be, but still having a role model or a mentor can really make a difference too. That's why I think I see that not many students benefit from mentorship program at ISER Bhopal, but I feel that more students should come forward and take advantage of having a mentor and going to them for advice, not just academic but even personal advice. Sometimes it becomes important.
So we also have some questions from the students,
Okay.
and so the first question is by Rajat Bakshi. He wanted to know how can a student from an economically weaker background pursue academia, as in this field getting a stable career might take some time.
So, at the moment, it did not exist about 2 decades ago when I was I and got enrolled in a bachelor's program. But at this point in time, there are several funding opportunities. There are several scholarships, fellowships that students can avail to pursue academics. Many a times, universities or institutions do not publicize, but they have provisions of giving loans or fee waivers to economically weaker students. So, those should also be explored. And also, it's not a bad idea to contact people, to approach people who, for example, if you want to do a PhD but you don't have the right kind of means to do PhD, you write to professors, you tell them your situation. If they find that you are truly motivated, they can give you a position. So networking also can be helpful in this regard.
So Ishit Ranjan had asked, I'm interested to take maths as a major here, but there are very less people who are choosing this as a subject. So is pure maths really difficult or different?
See, for me, history is very difficult. For me, geography is very difficult. So, what I want to say is that not everybody is cut out for a particular topic, and like you, I was talking to you. You said that you're an engineering sciences student, but you also love mathematics, right? So the point is, mathematics, along with some other discipline, can help you experiment both skills, your math skills, quantitative skills, as well as your experimental skills, let's say. But if you go into pure math, then it's only pure math, right? So many a times there are students who are interested in maths, end up taking other disciplines because, not because of fear of pure math, but because they want to do more with maths than just abstract maths. So and it's a global phenomenon that less students take maths because doing something purely in maths, which is not applied nature or something experimental, requires a lot of perseverance, dedication, working, dedicatedly in with pen and paper and so on. Not everybody is cut out for that. So I would say it's not. I mean, one should not choose mathematics because less students are choosing mathematics. If you feel that you are good in abstraction and logic at the same time and you like mathematics, even if numbers are small, just go for it, right? So it's a global thing that the number of mathematics students is less, right?
So Prajwal's question was, how should a second year student interested in pursuing physics as a major approach advanced math concepts? So should they study it in depth or simply use them without comprehensive understanding?
So, with my experience of teaching or interacting with physics students has been that their solution is driven by intuition, mathematics or a mathematics problem, rather as opposed to a mathematics major students who just want to do step by step, right? And a physics student would have some kind of intuition and they would come up with solution. If I ask them for a rigorous solution, they will not have, but their intuition is so strong that it drives them to that solution. So I would say maybe at less advanced stages like an undergraduate, it's okay to use mathematics as just a tool. Just take formulas and just apply and take theorems as statements and apply. But if you want to be a serious physicist and if you want to pursue physics as a career, research career, then you will have to learn mathematics deeply, in depth. and not just superficially to be a good physicist or a good engineer in research, I feel.
So, Aditya Sinha wanted to know if you ever got a zero in any of your math courses.
Zero, no, but I've got as low as about 65 on 100 in my 11th standard. But I have a reason because, I should give a reason of why I scored so low. I, uh, I always hated memorizing formulas. And 11th standard, you are just bombarded with so many formulas of differentiation, this and that and everything, and I was never good at memorizing those. So therefore my 11th standard was really bad. After that, in 12th, I realized that if formulas is the problem, as soon as I used to get in the exam the answer script on the back sheet, quickly I used to write all the formulas that I had memorized so that I can just use them. So yeah, so 12th was okay.
Yes, ma'am. So, thank you, ma'am, for sharing your insights and experience. Your advice have undoubtedly resonates with our audience, and we hope to see more of you. And we also sincerely thank the audience for their time.
Thank you, Yashaswini. I really enjoyed being part of this interview, and I do hope that my experiences would help other students who are watching this interview. Thank you.